There is a hard truth no one tells you about distributed systems. Every distributed system lies to you. The only question is, which lie did you choose to live with? If you have ever worked on a distributed system and thought, this shouldn't be this hard, you are not alone. At some point, every system breaks in a way that feels unfair, confusing, and almost personal. And underneath almost every one of those failures, there is a simple rule quietly doing its job. It's called the CAP Theorem. Today, we are not doing definitions you memorized and forgot. We are going to talk about how CAP actually shows up in real systems, why outages feel so chaotic, and why most arguments about databases are really arguments about trade-offs people don't want to admit they are making. Let's start with the dream we all have at the beginning. You build a system, you add more servers, you put them in different regions, everything is fast, everything is correct, nothing ever goes down. On paper, it looks beautiful. On a whiteboard, it's flawless. And for a while, it even works, until reality shows up. A network slows down, a data center drops packets, a cloud provider has a small incident. Someone cuts the cable somewhere you have never heard of, and suddenly your system has to make a decision immediately without even asking you. That decision is what CAP is really about. CAP stands for consistency, availability, and partition tolerance. But those words sound smarter than they need to be. So make them normal. Consistency just means if data changes, everyone sees the same truth, no matter which server they hit. Availability means the system always responds. You ask something, you get an answer. Partition tolerance means the system keeps running even when parts of it can't talk to each other. And here is the key part that people like to skip over. In distributed systems, network partitions are not rare. They are guaranteed. So partition tolerance isn't a feature, it's a requirement. Here is the real CAP rule, stripped down to the bone. When a network partition happens, you must choose either consistency or availability. You don't get both, you can't. This isn't about opinions. It's not about best practices. It's not about which database you like. It's a constraint of reality. CAP does not matter on good days. When the network is healthy, you are consistent, you are available, life is easy. CAP only shows up on bad days, during failures, during latency spikes, during outages. And failures are not edge cases. They are part of the system. So if someone says, our system is CA, what they really mean is, our system is CA until something breaks, and something will always break. CP systems choose consistency and partition tolerance. When something goes wrong, they slow down, or they reject requests, or they return errors. But they don't lie. These systems say, I would rather say no than give you the wrong answer. This is what you want when money is involved, inventory is limited, seats can't be double booked. Banks live here, airline reservation systems live here, payment systems live here. If you have ever seen a message like service temporarily available, that's a CP system protecting itself. It's annoying, but it is safe. AP systems choose availability and partition tolerance. They always respond, even if the data might be a little wrong. Different users might see different values. Data will eventually sync up. This works when slight inaccuracies don't matter, user experience matters more than precision. Social media lives here. Feeds, likes, view counts. If your like count is off by one, nobody panics, right? Nobody sues you, nobody loses any money. CA systems are consistent and available, as long as nothing goes wrong. They do not tolerate partitions. The classic examples for it is a single database on one server. Fast, correct, and simple. But the moment you distribute it, partition tolerance becomes unavoidable. So true CA systems only exist when you pretend the network can't fail. It can, and it always will. Let's give an example for it. That example is related to a bank account. This example makes everything painfully clear. You have $100. Your data is stored on two servers. They replicate data. Now the network splits. The servers can talk to each other. Server A lets you withdraw $100. Your balance is now $0. At the same time, server B still thinks you have $100. Now what? If the system is AP, server B also allows a withdrawal. You just turned $100 into $200. That's not a bug, that's a disaster. If the system is CP, server B refuses the request, you get an error, you are annoyed, but the bank survives. So therefore, banks always choose CP. They prefer angry customers over missing any money. That forces you to admit something engineers don't like admitting. You cannot have perfection. You have to choose who gets hurt, how badly, and when. Most production outages are not caused by bad code. They are caused by bad assumptions about failure. SAP exposes these assumptions. Here is something subtle but important. A server that responds in 10 seconds might as well as be dead. So systems treat slow nodes as failed nodes, which means high latency triggers CAP decisions, even without a hard network split. This is why timeouts are not just performance tuning, they are design decisions. Eventually consistent sounds friendly. It means the data might be wrong now, but it will be correct later. This works great for feeds, metrics, logs, and caches, but it does not work for money, seats, quotas. Eventual consistency is not a technical compromise, it's a business one. Amazon learned this early. They needed a site that never goes down, even during failures. They chose availability. That decision led to Dynamo, which later became DynamoDB. Their logic was simple. A wrong shopping cart is better than a dead website. Dead websites make zero money. Netflix assumes failure is always happening. Services disappear, latency spikes, networks glitch. So they design AP systems that degrade gracefully. They don't fight CAP, they design around it. You can tune CAP away. No, you can only choose how it hurts. Strong consistency is always better. No, it's slower and more fragile. CAP is just about databases. Wrong. It applies to APIs, services, caches, anything that crosses the network. Not which database is best, but what failure am I willing to accept? Wrong data, downtime, partial functionality. CAP is a business decision pretending to be a technical one. Here is the real takeaway. CAP is not a limitation, it's a mirror. It shows you what you actually value when things break. If you don't choose intentionally, your system will choose for you, doing an outage while users are watching. Distributed systems are hard because reality is messy. Networks fail, latency lies, perfect systems don't exist. CAP doesn't make systems worse, it makes them honest, and systems fail better. In the next episode, we will talk about how real databases secretly band CAP in production. Subscribe so you don't miss it, and I will see you soon.